Hello students, welcome to Vision IIT-NEET Academy. So today, as you know, that the JEE main is very near. So we are, because of you people, we have come to, we are launching this program where basically we will be covering the topics of NCERT in detail. Okay, and each and every chapter of NCERT is going to be covered in depth, and I hope that you will get full benefit of this class, because in this class our main focus is to clear the concepts in with as much clarity as possible. Along with that, there are some very good numericals which you can expect in your examination. So today with this I am going to start with a very important topic in physics, class 11 physics, as you can see, that is motion in a straight line. This is also called motion in one dimension. Okay. So this belongs to physics class 11, motion in a straight line. So first and foremost, I'd like to discuss the topics, briefly, what I am going to cover, what is going to be our agenda of today's class. We will cover position, reference point. Then I am going to talk about distance and displacement, where we will be discussing the difference between distance and displacement, what is meant by distance and what is meant by displacement, followed by velocity, speed and acceleration, right? Then we'll be talking about average velocity, average speed and average acceleration. Then we'll be talking about retardation, which is nothing but negative of the acceleration, reaction time, graph, and we'll see what is known as how many kinds of motions are there. We'll discuss about uniform motion, non-uniform motion briefly. Okay. First and foremost, before starting anything, we have to start with certain basic terminology in physics. What is that? That is called position and reference point. Say for example, when I am saying that, suppose you are saying that a train is moving. Okay. So you say that a train is moving. But if I tell you, if I ask you, the train is moving with respect to what? So you will say that the train is moving like when I am standing in the on the platform. Okay, you are standing on the station, on the platform, and you see a train passing by. A train is passing by. So that means, what is the reference point? The reference point becomes your standing position. If I say that anything, not only about movement, if I say that with same thing, we can say about distance as well. If I say that what is the distance of your school? Now this is this statement is not something which is quite clear. But if I ask you that what is the distance of your school from your home, then this statement becomes clear, and you can say that, okay, sir, it is about 5 kilometers or whatever it is. So that means here the reference point that we are actually keeping is basically your home, and you are measuring the distance of your school with respect to your home. So we have to have a reference point, okay, to define the motion or position, whatever you call. Now in this chapter basically belongs to kinematics. We will be focusing on the motion, but we will not focus so much why the motion is taking place. That thing we will do in Newton's laws of motion, which will tell us, there we will see that why motion takes place. So here we will be basically studying on the types of motions. Okay. Okay. Now this is something very important I need to discuss, that is rest and motion. First and foremost, if I ask you, I'd like to ask all of you to please look at the picture which is given here. Please look at the picture which is given here. If I ask you that by looking at this picture, please tell me which object is moving, कौन सा object move कर रहा है और कौन सा object stationary है, whether the tree is moving or the car is moving, which object is moving and which object is stationary. You can say that, sir, this is quite a normal question. The car must be moving, the tree is stationary. This is our perspective. All of us will say that only. But now think it in a different manner. Say for example, think like this, that you are driving the car. You are sitting inside the car. When you are inside the car, what will you see? Will you see yourself moving? Inside the car, when you are driving, you see everything stationary inside, isn't it? The steering, the gear of the car, everything what is there inside the car is basically stationary. But outside world seems to be moving to you. So if you are sitting inside the car, then the tree is going to move. You will say that with respect to the car, basically the tree is moving. But someone standing under the tree, that person is going to say that no, the tree is not moving, the car is moving. Because tree is stationary only. Then who is right here? This is the world of physics. And we will answer these kind of questions only. Okay? In real world, both are right. You cannot say there is nothing called absolute motion. So it is all relative. Depends upon the reference point that we just talked about. So when you are inside the car, to you the tree is moving and you are also correct. And the person who is standing under the tree, he is saying that the car is moving, the tree is stationary, he is also correct. So it all depends upon from which position we are actually defining the motion. Okay. Now we will come to a very important concept which is called distance. So if I would like to ask you that what is distance, what is meant by distance, you will say that, okay, distance is something which all of us know, that is the total path traversed or traveled by a body during its motion is called distance, right? Say for example, let us put it in a very simple manner. Say for example, this point is my point A. This is my point A. And this is my point B. Now, suppose you have traveled from point A to point B. Like this, you have gone. So, like this is the path that you have traveled. So, if I ask you that what is the distance that you have moved, then you will add up the entire path, all the path that you have covered, okay, from point A to point B. That is going to be your distance. So distance is the length of the total path traveled by a body during its motion. That is exactly what we call distance. And what is displacement then? Now distance is another thing that we need to focus is, here we are just considering the length. If I am talking about distance here, I am just considering the length or the magnitude of the path. What is going to be my total magnitude of the path? I am just considering that. I am in distance, we do not consider the direction. So distance is fully, we can say it is a scalar quantity, right? Now, when we talk about displacement, what is displacement? Displacement refers to the change in position of an object in a particular direction. What is meant by that? Let us put it in a more simple manner. Say for example, the same diagram I have taken, see, the same diagram, basically, the diagram for the distance as well as for the displacement. Okay, it is the same diagram. So here you are starting from point A and you are going to point B, and suppose the path followed by you is the same. You have followed the same path. Now if you are asked to find the displacement, not the distance this time, then what is the displacement covered by you? You will say that displacement is nothing but we will just look for the final position and the initial position. So what was our starting position? My starting point was point A. This is my starting point. And what is my final point? That is my point B. So the shortest distance between the final point and the starting point is going to give me displacement, is going to give me the value of the displacement. So you join the starting point and the final point. Okay. So the length, this length AB, the length AB gives you displacement. So this length gives you displacement AB, right? And what is going to be the direction? Because this is a vector quantity, I have said. Then what is going to be the direction of the displacement? The direction is going to be from the starting point to the ending point, from A to B. So you see the direction here, you can see the arrow here. From the starting point to the ending point is the direction. So this is what is meant by displacement. Okay. Now let us solve a question. See what the question is talking about. It is saying a boy traveled 4 meters in the north and 3 meters in east. Find its distance traveled. So there we only want the distance. So what is the distance? Distance means what is the total length traveled. Let us see. So someone is covering 3 meters in the east. So this is 3 meters, right? Followed by 4 meters in the north. This is 4 meters. Now if I am talking about the distance, then we know that distance is nothing but total length of the path covered. So distance is going to be here 3 meter plus 4 meter. So distance is going to be 7 meter because this is the total length which has been covered from O to A to B. So total length covered is, we can say, OA plus AB, and that is equal to your distance. Okay. Now the same thing, but now we have to find out the displacement. So look at the question now. A person moves 3 meters to the east and then 4 meters to the west. Determine the displacement from the starting point. You are asked to determine the displacement from the starting point. Suppose this we will solve in two ways. One is we are going to solve it graphically, and second we would like to solve it vectorially as well. Because you know displacement is nothing but it is a vector quantity. So a person moves 3 meters to the east. So we all know the sense of direction. So we all know the sense of direction here. The sense of direction is so if I draw this is my north side, this is my east side, this is my west side. Okay. Now, what we are talking about is, suppose a person moves 3 meters to the east. So in the east side, the person has moved 3 meters. Okay. So 3 meter the person has moved in the east. Then 4 meters to the west, followed by from this point. From this point itself, the person is now moving to the west. From this point itself, the person is moving to the west and 4 meters. Right? So this was my starting point, 0. Now when the person is moving 3 meters in the east, followed by 4 meters in the west. So 4 meters this is 3 meters. This much is 3 meters. 4 meters is going to be how much? From here again you are traveling back. So this entire is your 4 meter. So what is the displacement? If you are asked about the displacement now, what is the displacement? Displacement means what is your finish point? You have to first say, this is your finish point or the end point. I'll call it E. Okay. So this is my E. Right? And this is O. So the displacement becomes from finish point to end point distance, and that becomes nothing but 4 minus 3, 1 meter. So 1 meter is the magnitude of the displacement you are having here. But in which direction? What will be the direction of the displacement? The direction is going to be from the starting point towards the ending point. So I will say 1 meter towards west. One meter towards west. This is going to be your displacement. So okay, let us now focus on this problem. What it is talking about? A person first moves 3 meters east, then 4 meters north, and finally 5 meters up. Okay, determine the displacement from the starting point. Now this is where our vector algebra comes into play. Okay, here they are actually asking you the displacement, so you very well know that all you need to do is the starting point and the ending point. We need to join and the shortest distance between the two. So let us see how vectorially we are going to solve it. So I can say that it has moved 3 meters east. So east direction I am saying this is my I cap. North direction we are putting as j cap. And perpendicular to the plane of the paper or the plane of the board is my k cap. So let us put it in that way. Then I can say that 3 I cap, my displacement is 3 I cap plus 4 j cap, right? plus 5 k cap. Now if that is so, this is the displacement vector. So this entire is a vector 4 I cap, 3 I cap plus 4 j cap plus 5 k cap. And what is going to be the magnitude of this displacement vector? Or what is the magnitude of this displacement? You know that it is nothing but root over 3 square plus 4 square plus 5 square. So it is going to give you something like root over 9 plus 16 plus 25. So root over 25 plus 25 gives you root 50, and root 50 is 5 root 2. Right? So our displacement becomes, the magnitude of the displacement becomes 5 root 2. So though this sum may seem to be difficult, but you can very easily solve it through vectors, and this is exactly what I would like to discuss here. Right? Similarly, we are having a similar kind of a problem where it is talking about a person first moves 3 meters east, then 4 meters north, and finally 5 root 2 meters up. Okay? Determine the displacement from the starting point. Again, they are asking you to find out the displacement from the starting point. So let us solve it. So same thing, we are going to just write the displacement as 3 meters east. So I am going to put 3 I cap plus 4 meters north. So I am going to give it as 4 j cap, and 5 root 2 meters up. So 5 root 2 k cap. Right? And my work is done basically. So my displacement magnitude, what I am going to get is root over 3 square plus 4 square plus 5 root 2 whole square. So if you compute it, you will get root over 9 plus 16 plus 50. So you will get 25 plus 50, right? Root 75. So your displacement is nothing but, the magnitude of your displacement is going to be root over 75. Okay. Now, see, they are now asking you directly from vector notation, and they are saying that a particle goes from 3 I cap plus 4 j cap to 5 I cap plus 7 j cap. Calculate the displacement between these 2 points. So first and foremost, let us suppose that this is my point O, and what is this point all about? This is having 3, 4 coordinates, and this is my point, another point A, which is having a coordinate of 5, 7. Right? So if that is so, then they are asking you about the OA vector, because your OA vector is nothing but your displacement vector. So OA, so starting point is O, ending point is A. So what I can do here is that you just take up the coefficients of I cap. So it is final minus initial, so 5 minus 3 I cap plus 7 minus 4 j cap. So your displacement vector or OA vector is nothing but 2 I cap plus 3 j cap. Right? So this is in vector notation, this is your displacement vector. And if you are asked about the magnitude of it, what is going to be the magnitude? It is going to be root over 2 square plus 3 square. 4 plus 9. So that is root 13. So the displacement is, so the magnitude wise OA is basically nothing but root 13. Okay. Now there is a statement and it has been asked the correct statement among the following is. Which is the correct statement? We need to read it very carefully. Now when displacement is 0, distance travelled is not 0. Okay. They are saying when displacement is 0, distance travelled is not 0. Okay. When displacement is 0, distance travelled may be 0. When distance is 0, displacement is not 0, and when distance travelled and displacement are always equal. Now let us find it out. Now first statement, what they are saying, when displacement is 0, distance travelled is not 0. Suppose I am taking an example where a person is starting from this position O and it has travelled from O to A, and then from A it has come back to O. Okay, then my starting point and ending point is the same, so my displacement is becoming 0, but my distance travelled is not 0. So apparently option A may seem to be correct, but there can be another case where basically the point has not moved only. So then my displacement is also 0 and the distance travelled is also 0. So going by that, we should go for option B, because when displacement is 0, distance travelled may be 0. If the particle has not moved, then displacement and distance travelled both are 0. But if the particle has moved and come back to its initial position, then my displacement is 0, but distance will not be 0. So correct option is going to be our option B. So you see, the correct option is our option B. Okay. Now we will talk about speed. Now what is speed? Speed is a physical quantity that measures how fast an object is moving, right? Or simply say, it is magnitude of velocity. So speed means that how fast its position is changing with respect to time. If I talk about, suppose I say that I am plotting a graph. Suppose we are plotting a graph here. Okay. So this is basically the x or the position. Okay. And this is the time. With respect to time, how the position of a particular body is basically changing. So speed is going to give me, if I have a graph x versus t, that is the position of the particle versus its time graph, speed is nothing but the slope of this. Okay. So how the rate of change of position, that we call basically speed. So speed is nothing but the rate of change of position. Say for example, if it is changing something like this, so I can say that at a point from t1, when it was at time t1, its position was at x1. Okay. And at time t2, the position was x2, right? x1 this is, and this is x2. Then the speed is going to be given by, speed will be given by the slope of this graph. And what is the slope of this graph? The slope is nothing but x2 minus x1 divided by t2 minus t1. So rate of change of position with respect to time. So we can say that speed is rate of change of position with respect to time. So how my position is changing. Now, average speed. Speed though we have understood. Now what is average speed? Average speed means, always we keep in this point, we average speed we define in this kind of a thing, in this way, that average speed is nothing but it is the total distance traveled divided by the total time taken to cover that distance. Okay, so it is calculated by dividing the distance traveled by the time taken. Speed has no direction and it is a scalar quantity. This we have already seen. So average speed is total distance by total time. Okay. Now suppose an object moves x1 distance with speed v1, okay, and x2 distance with speed v2. Then find the average speed of the total journey. So just now we talked about average speed and we'll see that. See, average speed means total distance by total time. Right? So what is the total distance here? It is saying an object moves x1 distance. So total distance is nothing but, in this case, x1 plus x2. That is my total distance. And this is the x2 distance. And okay, x1 distance it has basically covered with speed v1. Okay. So what is the time t1 taken? What is the time t1 taken to cover this x1 distance? This time is going to be nothing but x1 by v1, right? Similarly, t2 is going to be, my t2 is going to be x2 by v2. So we have, now we have the total distance x1 plus x2 and we have the total time t1 plus t2. So just we are going to put the value. So this is my average speed. So this is going to be okay. So this is nothing but x1 plus x2 into v1 v2 divided by x1 v2 plus x2 v1. Okay. Now, this is a very interesting question. A particle is moving such that its position coordinates xy are 2, 3 at time t is equal to 0, 6 meter, 7 meter at time t is equal to 2, and 13 meter, 14 meter, 13, 14 at time t is equal to 5. The average velocity, okay, the average velocity vector from t is equal to 0 to t is equal to 5 second is. So we need to find out the average velocity here. Okay, in order to do that, first and foremost, let us put all the coordinates, whatever they have asked us to do. A particle is moving such that its position coordinates x comma y are. So first at t is equal to 0, if I write t is equal to 0, here the coordinates are 2 comma 3, 2 meter, 3 meter. So this is my 0. Okay. From here it has moved, suppose here, another point where this is the time, t is equal to 2, t is equal to 2 second, and here it is 13 meter, 14 meter. And from here, basically, no, here it is 6 and 7, sorry. So here it is 6 meter, comma 7 meter, right? From here it is moving to another point, I can name it as P, where it is 13 comma 14, 13 meter comma 14 meter. So this is at time t is equal to 5 second. Now you are asked to find out the average velocity vector from t is equal to 0 to t is equal to 5 second. So see, the point here is actually to find out the average velocity, what we do, average velocity is the final position minus the initial position divided by the final time minus the initial time. That is my average velocity. Or I can say the average velocity is nothing but the final displacement minus the final point minus the initial point. Okay. So here the final point is my 13. This point, my point P is my final point and my initial point is point O. Right. So this I actually don't require. Point A not required to find out the average velocity. So my velocity average vector, it is going to be, this is just going to be 13 minus 2 I cap plus 14 minus 3 j cap, right, divided by 5 minus 0. So this is T2 minus T1. So you can write it like, this is nothing but 11 I cap plus 11 j cap by 5. Okay. So you can take 11 common from here. So 11 I cap plus j cap by 5. So this is the answer. So answer is going to be option D. See, it is option D. Right. Okay. A car travels from Kota to Jaipur with speed 30 km per hour and it returns along the same path with speed 60 km per hour. Calculate the average speed of the car. So it's the same thing. Average speed means total distance by total time. So average speed is total distance by total time. So what is the total distance that it has actually covered? Suppose I don't know the total distance because it is not given here. So what we'll do, let us suppose that from Kota to Jaipur it is D. Okay. And it has also returned the same path. So it is, the total distance is basically 2D. Right. And it returns along the same path with OK. And what is the total time? My time T1 is going to be, in first case it is D by 30 and in the second case it is going to be how much? D by 60. Okay. So this is my T1 and this is my T2. So 2D divided by, we have like it is 60, 2D plus 1. plus d, right? So I'll have 2d into 60 by 3d, right? dd getting cancelled. So it is basically 40. So average speed is going to be 40 kilometer per hour. This is the average speed that we will get. Now there is, all this I have done, but there is one trick, or I should say we can call it a trick, okay? So which we should keep in mind, that average speed is nothing but if the distance is constant, it is if the distance is same in between the same distance, like here Kota to Jaipur the same distance, so then you will get the average speed as if yours one in one go, if the speed is x kilometer per hour and in the next go it is y kilometer per hour, then average speed you will get as 2xy by x plus y, where x is speed 1 and y is your speed 2. Okay. So if you remember this problem, this formula, a lot of time we can actually save. Okay. Now see, instantaneous velocity. What we basically mean by instantaneous velocity? Instantaneous velocity means the rate of change of position at a particular instance I want to measure. What I mean to say by this, suppose I have drawn a curve. Okay, we are drawing a curve, something like this. So suppose this is nothing but my x, that is the position, and this is my time axis. Now my x versus t is basically changing. Suppose this is the graph, this is how it is changing. Okay, the position is changing with respect to time. Now at a particular instance I want to find out what is the velocity. Then what I mean to say is that suppose I want to find out the exact velocity at a particular time t is equal to t1. Suppose this is the time of t is equal to t1. So at this point, what is the instantaneous velocity that actually I want to measure? That is going to be given by the slope at this point. The slope, exact tangent. So this is nothing but the tangent. So I have to draw a tangent at that point, and the value of this tangent is actually giving me the rate of change of position at that particular instance, that is at time t is equal to t1. So this is nothing but what we call v is equal to dx dt at time t is equal to t1. So this is how we write it. V is equal to dx dt at time t is equal to t1. The same thing they have actually written. Okay, so if your position vector is like x I cap plus y j cap plus z k cap, if you are differentiating it, v is equal to dr dt, then with respect to time, if you are differentiating it, you will have to have this dx dt I cap plus dy dt j cap plus dz dt k cap. Okay, and what are all this? Dx dt I cap, what is it? It is nothing but vx, I can say now. So this is vx, velocity along the x direction. So vx I cap plus vy j cap plus vz k cap. So this is nothing but v. Okay. Now let us solve this question. The position of an object is given by, so they have given you the position, it's the function of time. Then find the magnitude of the instantaneous velocity at, we need to find the magnitude at the instantaneous velocity at time t is equal to 0 second, t is equal to 1 second, and t is equal to 3 second. Okay. Velocity we need. So velocity is nothing but dx dt. So I am going to, so and they are talking about instantaneous. So first I am going to find out at t is equal to 0. So let us differentiate this. If I differentiate this equation dx dt, what it becomes? It becomes 2t plus 6. Okay. Now at time t is equal to 0, it is going to be, you see, 2 into 0 plus 6, you are going to get 6. So my answer is going to be, here velocity is going to be 6. Okay, unit they have not given. So let us just write 6 here. Okay, meter per second it should be. Okay. Now at t is equal to 1 second, what is the velocity? Same, the expression is just the same. So you can use this expression only. I have differentiated it and got it. So at t is equal to 1 second, so 2 into 1 plus 6, this is going to give you 8. So it is v is equal to 8 here. Okay. And t is equal to 3 second, at t is equal to 3 second, you are going to get, this is at t is equal to 1, t is equal to 3, you are going to get 2 into 3 plus 6. So it is 6 plus 6, 12. Okay. Now average acceleration. So average acceleration is nothing but, it is the rate of change of velocity. Like velocity is nothing but rate of change of the position, we can say. Similarly, acceleration is nothing but, it is determining the rate of change of velocity. In what rate the velocity is changing. Okay. So if I plot a curve, something like this, again, and this time I am going to plot the velocity versus time. So if this is my, if the y-axis is basically representing my velocity and x-axis my time, and I have a plot like this, v versus t, and if the curve is something like this, I can say that the slope of this curve is nothing but acceleration. Okay. That means the rate of change of velocity, if I have taken, this is t is equal to t1, my velocity is v1. Okay. And at time t is equal to t2, what is my velocity? It is v2. Okay. So the slope, that is the acceleration, is nothing but v2 minus v1 by t2 minus t1. That we can say that, tell this as del v by del t. That is the change in velocity divided by the change in time. Now when I am going to find out the instantaneous acceleration, at that time my this delta t is going to be approaching towards 0. So we say that instantaneous acceleration instantaneous is nothing but del v by del t, where limit delta t tends towards 0, it is nothing but del v by del t. This is also written as instantaneous acceleration is nothing but dv dt. Anyways, and if I am calculating the average, then change in velocity by the change. Particle is initially moving with a velocity of 4 meter per second in the east direction. After some time, its velocity becomes 4 meter per second in the north direction. What is the direction of the average acceleration of the particle. Okay. Now they are asking about the direction of the average acceleration. Very, very easy if we follow vectorially this method. So initially moving with a velocity, so this is Vi, I'll just write. Initially what was the velocity? Suppose like I said that this I am taking the east direction, let us consider I cap. North direction, let us consider j cap. Okay. So V initial 4, it was 4 I cap. Okay. And V final, what is my V final? Velocity becomes, okay, it is basically 4 j cap. Now you see, they are asking about what is the direction of the average acceleration. So what is going to be my average acceleration? So if I talk about the average acceleration average in vector terms, I don't know the time they have also not given, it's not required as well. It is going to be anyways Vf minus Vi, okay, divided by some delta t. Now time is a scalar quantity, so it is not going to affect my vector anyways. So what I can say is it is nothing but 4j minus 4j cap minus 4I cap by delta t. From here what I can say is it is nothing but I can say minus 4I cap plus 4j cap by delta t. So what it means? I cap in the negative. That means the direction is towards this side, we should say negative I cap. So it is the west. And j cap, we are getting another component along like this, j cap. So net resultant, where should we get? Where should be our net resultant? The resultant should be along this direction, right? This is going to be the resultant, which is northwest. So what is the direction of the average acceleration? The direction of the average acceleration is in the northwest direction. Okay. So this is how we can find it out. Okay. Now instantaneous acceleration, the same concept. In case of instantaneous acceleration at a particular time, if you are asked that what is the change in velocity at that particular instance, then we say that that is nothing but the instantaneous acceleration. Okay. And average acceleration is rate of change of velocity. For a substantial amount of time we are taking it. Okay. So if v is equal to 3t square, find acceleration, they are saying. So v is equal to 3t square. So this is the equation, velocity equation with respect to time, function of time you are given. Now you are asked to find the acceleration. So acceleration you know that it is nothing but dv dt. So very easily you can say that it's 3 into 2t. So the acceleration is going to be 6t. This is going to be your acceleration. So acceleration here, what we can infer? The acceleration here is not constant. You see, a very important conclusion we can draw from here is acceleration kaisa hai? Acceleration is also a function of time. I can say that if I put t is equal to 0, my acceleration is going to be 0. If I put t is equal to 1, my acceleration is 6 meter per second square. If I put t is equal to 2, it is 12 meter per second square. So acceleration is also increasing with time. So acceleration is increasing linearly with time. So if I plot here the curve of acceleration versus time, the plot acceleration versus time, then how the curve is going to be? It is going to be a linear curve, something like this. So with time, acceleration is basically increasing, right? Okay. Similarly, look at this question. V is equal to 2t square I cap plus 3t cube j cap. Find acceleration. They want acceleration from you. Simple, we'll just differentiate it. So acceleration is nothing but dv dt. You just differentiate, you will get 2 into 2t I cap plus 3 into 3 t square j cap, right? So you will get here 4t I cap plus 9 t square j cap. This is our acceleration. So this is also, we can say that it is the what kind of an acceleration it is? It is not a uniform acceleration, it is changing with time, because in both the I cap and j cap, you see the time is there, but in case of I cap it is linearly. So x axis, the acceleration is linearly increasing, but in y axis or whatever you can say, along the j cap, the acceleration is increasing at a much faster rate. It is parabolic. Okay, it's t square. So square term is there. So my increase in acceleration is more along the y axis compared to along the x axis. Okay. The position of an object is given by, so another equation is given where the position of the object is x is equal to t square plus 6t plus 5. Then find the magnitude of the acceleration at, you are asked to find out the magnitude of the acceleration. Mind you, you are asked to find the magnitude of the acceleration. So they have not asked you to find the magnitude of the velocity. So you have to differentiate it twice. So acceleration is nothing but, you know, acceleration is nothing but dv dt, and velocity is nothing but dx dt. So from here we can say that a is equal to d2x dt2. That is double differentiation of the x, that is the position. Okay. So what we will do here, we'll simply differentiate it once to find the velocity, and then the velocity is going to be again differentiated. So you see the velocity term, what we will get if we differentiate it once, 2t plus 6. Okay. Then the acceleration term is going to be dv dt, and if we again differentiate it, it is going to be 2, because this 6 is a constant. So you get 2. So acceleration is not a function of time itself. So you see there is no time involved. Acceleration is purely a constant, 2 meter per second square. So at time t is equal to 0 also, as it is not a function of time, you will get acceleration to be 2 meter per second square. At time t is equal to 1 also, you will get acceleration to be 2 meter per second square. At time t is equal to 3 meter also, you will get acceleration to be 2 meter per second square. Now, we talked about acceleration. Similarly, we can also talk about retardation or deceleration. Now, what is retardation or deceleration? That is nothing but negative acceleration. What is negative acceleration? Negative acceleration means acceleration is what? Rate of change of velocity. Now, when the rate of change of velocity is positive, okay, that is the velocity is increasing constantly, we say that our acceleration is basically positive. Okay, we call it positive acceleration. And negative acceleration means, suppose we have a velocity versus time graph, something like this. This is our velocity and this is the time, and the plot is like this. What it means is that, you see, at time t is equal to 0, my velocity was somewhere here. Okay, my velocity was somewhere here, vf. Okay. Now at time, but with time, as my time is increasing, what is happening to my velocity? It is decreasing. So at any time, let us not call it vf, okay, let us call it vi. Vi initial. At any time, vf is going to be definitely less than vi. At a particular time t is equal to, suppose at t is equal to 1, now this is t is equal to t. I want to find out at a particular time, t is equal to t prime. What is going to be my velocity? This is my final velocity. I can say that this is nothing but Vf. Okay. Now acceleration is nothing but Vf minus Vi. Vf minus Vi divided by delta t, that is t prime minus 0. Here because this is 0. Now this is negative because my Vf is less than Vi. Okay. So this is going to give you a negative value. Vf minus Vi is going to give you a negative value. Why? Because Vf is less than Vi. Okay, from the graph. So it is having a negative slope. This kind of acceleration we call retardation. Okay, a common example is, say for example, you have thrown something up. When you am throwing this pen up like this, what is happening? This pen is moving, okay, going up to a certain distance and then it is stopping and then again it is falling. So just consider this, like it has stopped after moving some time. Okay, so the speed is, initially I have given it some speed, but the speed is basically decreasing, velocity is decreasing, keep on decreasing, and then it is becoming 0. That what we call nothing but retardation or deceleration. Okay, now we'll be discussing about the different types of linear motion. So the first motion that I would like to discuss here is what is called the uniform motion. Uniform motion means when the distance traveled by an object with respect to time is basically constant. Distance or the displacement traveled by an object with respect to time is constant. What I mean by this? That means that, you see, if I am plotting a curve like this, if I am plotting a curve like this, okay, and this is basically nothing but the distance. Okay, let us take it as x. So this is x versus t. So x is uniformly increasing or uniformly decreasing, whatever. It can be like this also. Then I say that yes, the distance, this is the distance, y axis is the distance. With time the distance is uniformly increasing. That means what I can say from here is that the slope is basically constant. The slope is basically constant. Right? The slope of this curve is constant. That means dx dt is a constant. That means for uniform motion, what is this dx dt? This we call nothing but velocity. So velocity or the v value has to be constant. Okay? It is basically moving with a constant velocity. Something moving with a constant velocity, we call it uniform motion. Now tell me one thing. Can a uniform motion be accelerated? अगर कोई मोशन, कोई एक बॉडी अगर यूनिफॉर्म मोशन शो कर रहा है, क्या वो एक्सीलरेशन कर सकता है? Can that ever accelerate? No. The answer is no. Because you see, for uniform motion, what it is? The main criteria is the velocity has to be constant. Now, if the velocity is constant, that means what? That means dv dt is equal to 0. Okay? That means acceleration is equal to 0. So, this is another way you can remember the uniform motion. So, I can say that uniform motion will have velocity constant and another thing is acceleration should be 0. This is something which we can talk about if I am talking about uniform motion. Non-uniform motion, anything out of the uniform, which is outside the ambit of uniform motion, is basically non-uniform motion. So non-uniform motion we have like where the velocity is not constant. Velocity is not constant. So accelerated motion are also non-uniform motion. All the accelerated motions are non-uniform motions. Okay. And uniformly accelerated motion, okay, this is a special type where accelerated, in case of acceleration also it is uniformly, it is accelerating. So if I plot, this is also non-uniform. Okay, uniformly accelerated motion is also a non-uniform motion, because if I plot a curve for A versus t, acceleration versus time, it is saying that it is going to be uniformly accelerated, either upward or downward, whatever you say. But you see the dA dt is a constant. So this slope is constant, dA dt. Okay. So this is basically for uniformly accelerated motion. We have another problem which talks about the motion of a particle along a straight line is described by the equation. So the equation of the motion of the particle is basically given to you, and it is x, that means it is the position equation. X is equal to 8 plus 12t minus t cube, where x is in meter and t in second. The retardation of the particle when its velocity becomes 0 is, so we need to find out the retardation or the negative of the acceleration of the particle when its velocity is becoming 0. Okay. So velocity becoming 0 means, first and foremost what we will do is that we will find out the velocity first, and velocity is nothing but dx dt. So this is going to give us, if we differentiate, 12 minus 3 t square. Now they have said that when its velocity becomes 0, so my this term is basically 0, which means v is equal to 0. So here I can put 12 minus 3 t square to be equal to 0. That will give me, so t is equal to 2. So at 2 second, basically what I am having the velocity 0. So if I am having the velocity 0 at t is equal to 2 second, I will have to find the acceleration. Now the equation for the acceleration is going to be, I will have to again differentiate it, because acceleration is nothing but dv dt, right. So if I differentiate this, it becomes minus 60. Okay. So acceleration at time t is equal to 2 second is nothing but minus 6 into 2, I will get minus 12 meter per second square. So our option is going to be 12 meter per second square, but here as they are talking about retardation, that is why minus sign they haven't taken, right. Okay. The velocity of a body depends on time according to the equation. So this is again this is the velocity equation which is given to you. V is equal to t square by 10 plus 20. The body is undergoing. We need to understand, we need to find out the body is undergoing what kind of motion. Is it uniform acceleration, or is it uniform retardation, or is it non-uniform acceleration, or is it zero acceleration? So we will find out. Let us see. So velocity equation is given to you. So we all know that acceleration is nothing but dv dt. Okay. So I am just going to differentiate this. So it becomes 2t by 10. Then it is nothing but t by 5. So this is my acceleration, which is t by 5. It means that acceleration is a function of time. So as acceleration is a function of time, so I can say that the acceleration is linearly changing or increasing with time. So it is basically a non-uniform acceleration, because the acceleration is not uniform, it is basically changing with time, right? The position x of a particle varies with time t as, so again the position equation is given to you, and how the x is varying with respect to time. Okay, x is equal to at square minus bt cube. The acceleration of the particle will be 0 at time t equals to. So here we need to find out when our acceleration is going to be 0. When our acceleration is going to be 0, that time we need to find out. So we'll do it. So let us see. First and foremost, we'll find the velocity. Velocity is nothing but the dx dt. So I'm going to differentiate this. So we'll have 2at minus 3t square b, right? Now my acceleration is going to be d2x dt2. So it is going to be 2a minus 6tb. Now this equals 0 because they are saying that the acceleration of the particle will be 0. So this entire term I can write to be 0. Okay. So it becomes 2a minus 6tb is equal to 0. Then 2a is equal to 6tb. So from here we can say that time t is nothing but 2a by 6b. That means it is nothing but a by 3b. So our option is a by 3b, option B. Okay. Okay. So I would like to request all of you to please go through this problem once, read the question carefully, and then we are going to solve it. Read. So the problem states a particle moves along a straight line such that its displacement at any time t is given by s is equal to t cube minus 6t square plus 3t plus 4. The velocity when the acceleration is 0. They want us, so the point is the acceleration is 0. So we have to reach up to the acceleration equation. From the acceleration equation, we will get the time when the acceleration is going to be 0. That time we are going to put in the velocity equation. Let us see. So we can say that velocity is nothing but, I'll differentiate, I'm directly differentiating it. So 3t square minus 12t plus 3. Okay, this is your velocity. Acceleration is going to be 6t minus 12. Now the acceleration is 0. Okay, when so I can say the acceleration is 0, that means my 6t minus 12 is 0. T minus 12 is basically 0. So t you are getting as 2 seconds. Just put the value of t here. So v at time t is equal to 2 is nothing but 3 into 2 square minus 12 into 2 plus 3. So we'll get okay. So the velocity when the acceleration is 0 is, it is basically 9 meter per second, right? Now we would like to discuss some very important concepts here. The first and foremost I would like to show you the position time graph. What the position time graph talks about. So if I plot the position time graph something like this, that this is my position x and this is the time t. So along the y axis I have put the position which is x, okay, and along the x axis I have put the time. Now if I say that a body is stationary, that is the body is not moving, then how should be my position time graph from here? Body is stationary means we all understand that the body is stationary, it means that with respect to time its position is not changing. So my plot is going to be like this, parallel to the time axis. So my x is constant, okay. Now if I say that, okay, the body is now moving but uniformly, that means uniform movement means it is covering equal distance in equal intervals of time. Then how should be the plot? Let us see. Now the plot is going to be something like this, okay. So here when I talk about the rest, the body at rest, I can say okay, this is the body at rest. That means here if I differentiate the dx dt, that is the position with respect to time, I will get nothing but velocity, and velocity is 0 here because you see the slope is 0. The slope of this curve is basically 0. But here the velocity is not 0. We are having some positive slope here. So this is what is meant by the position time graph. Its slope gives you the velocity, right? Now if I talk about the velocity time graph, okay, let us focus on velocity time graph now. Okay, so this is my velocity and this is my time. If I say that the velocity is constant, what it means? It means that the body is definitely moving but at a constant rate. It is moving at a constant velocity, okay. So its speed is neither its speed is changing nor its direction is changing, okay. So we will call it a constant velocity, body moving with a constant velocity. And how I am going to plot it? This is going to be just similar, parallel to the time. So parallel to the time axis this is going to be, right. So here we can say that my dv dt is basically 0, right. So I can say that dv dt or the slope of this curve is nothing but 0. So here when a body is actually having a constant velocity, then the acceleration is basically 0. That is what we can infer from this graph, okay. And the next thing is when the velocity is increasing but at a uniform rate, then how I am going to plot it? Say for example, the velocity is increasing but uniformly, okay. So here what we can say is that obviously the slope is positive. So here it is increasing with respect to time, the velocity is increasing. And here I am going to say that for this curve my dv dt is definitely positive, but it is going to be a constant because the slope is constant here. So here my acceleration is basically constant. We'll have a constant acceleration in this case. Okay. Now, if I plot the acceleration time graph, now along the y-axis, I am going to write the acceleration, and along the x-axis, I am going to plot the time. Okay. So when I am plotting the acceleration time graph, again we can have two, more than that types. But the thing is, when the acceleration is constant, say for example, this kind of examples we can take, that a body which is falling freely under the action of gravity. So the acceleration is constant. The value of acceleration we take 9.8 meter per second square, or sometimes 10 meter per second square. So the acceleration is basically constant there. So the kind of graph that we actually can expect is, so we'll have a constant acceleration. Okay, with respect to time, acceleration is not changing. But even for a motion which is having a constant acceleration, can we say that that motion is basically uniform? A motion having constant acceleration? No, the motion is not uniform, because acceleration constant means velocity is keep on changing. With each and every passage of time, the velocity is changing. And whenever the velocity changes, we know that we are not going to call it a uniform motion. So always remember that even if any motion is having constant acceleration, that is an example of non-uniform motion only. You cannot say that it is a uniform motion, because in each and every second your velocity is changing under the action of the acceleration, right? And this acceleration may also change. Like say for example, in real life, actually in real situations, the acceleration changes also. For the simplicity, we do not consider it, but the acceleration may change with time. And then we can have various kinds of graphs, like the acceleration can be constantly increasing or decreasing or things like that, right? Okay. Now, so the position time graph for a body moving along a straight line between O, so this is point O, and A is shown in figure. So this is the position time plot which is shown. During its motion between O to A, how many times the body comes to rest? So comes to rest means the velocity is 0. So they are saying how many times the velocity becomes 0. You know, velocity 0 means, we all know that when the velocity is 0, when the dx dt is 0, I can say, so the dx dt 0 means, what does it mean? The slope of the x versus t curve is going to be 0. Dx dt is nothing but the slope of the x versus t curve. So the slope of the x versus t curve needs to be 0. So you now see how many points you are getting the slope to be 0. Is the slope 0 here? If this point I am talking about, no, the slope is not 0, it is positive. You draw a tangent here, it is positive. It is positive. But you see here, there is a particular point where the slope is becoming, the tangent is becoming absolutely parallel to the x-axis. So this is the point where the tangent is becoming absolutely parallel to the x-axis. So my slope is 0 here. I can say that at this point, my dx dt is equal to 0. Similarly, at this point, so this is a crest and this is a trough. At this point also, what is happening? The slope is 0. That means my dx dt is equal to 0. at this point as well. So there are two such points where actually I am getting my slope to be 0. So my answer is going to be option C twice. Okay. Now you see the displacement time graph for two particles A and B is shown. So this is the displacement time graph of two particles A and B is shown. Okay, this is the along the y-axis we have the displacement, and along the x-axis we have the time. Okay. Now the ratio VA by VB is, so what is going to be the ratio? So if it is a displacement time graph, the VA is going to be what? See, this is displacement versus time. So we need to understand VA, if I am talking about, that is going to be dx dt. That means VA is going to be nothing but the slope of this, curve, because this is A. Okay, so the slope of this curve is going to give me VA, right? So how much is this angle? If this total angle they are talking about 45 degree, this is 15 degree, right? This is 15 degree. So this is 45 minus 15. So the angle, this much angle I can say is nothing but 30 degree, right? This is 30 degree. Okay. So VA is going to be nothing but tan 30. Slope is nothing but tan of the angle. So this is tan 30, right? And VB is going to be, similarly VB is what? VB is this, the slope of this line. So the slope of this line is going to be 45 plus 15. So it is 60 basically. So it is basically 45 plus 15. Yes, 60. So it is tan 60. So if you are asked about VA by VB, it is basically they are saying that what is VA by VB means tan 30 by tan 60. Okay. So anyway your value is going to be 1:2. Tan 30 by tan 60 will give you a value of 1:2. Okay. Now the position of a particle X, see, look, the position of a particle X varies with time. Time is along the x-axis, S, as shown in the figure. The average acceleration of the particle, what is the average acceleration of the particle in time interval t is equal to 0 to t is equal to 8 seconds. So average acceleration average is nothing but the final velocity minus the initial velocity, that is the change in velocity by the change in time. Okay. So what is the velocity change here from 0 to 2? Say, what is the velocity change here? So it is changing 40 minus 0. Okay, not the velocity change, position change, x. So 40 minus 0. So let us see the velocity here. Okay, so if this is my 1, this is my curve 2, and this is my curve 3. So velocity, let us find out first. Velocity in curve 1. So I will call it V1. This is 40 minus 0 divided by 2 minus 0. So this is going to be 40 by 2, 20 meter per second. This is the velocity V1. V2 is 0. The velocity is 0 because it is not changing. The x is not changing. It is constant. So velocity is 0 at V2. So you can write V2 is equal to 0. And V3 you can write what is happening in V3? In V3 it is, the velocity is negative. And how much is it? 0 minus 40. 0 minus, finally is 0. from 40 it is becoming 0, that is the displacement, okay, divided by what is the time? The time is basically 8 minus 6. So it is minus 40 by 2 minus 20. Okay. So it becomes minus 20. Now minus 20 meter per second. Now the acceleration, they want average acceleration. Acceleration average, what it is going to be? Final minus initial. What is the final velocity? v3. So I can say v3 minus v1, because v2 is 0, divided by the total time del t. What is the del t? 8 minus 0. So this is minus 20 minus 20 divided by 8. So this is going to give you minus 40 by 8. So minus 5 meter per second square is the answer. Acceleration is going to be minus 5 meter per second square. So option C is the, so option B is the correct option here. Okay, now I would like to request you to read this problem once and then we are going to solve it. Okay. Okay. Now let us see the position x. So this is basically showing you along this axis, it is showing you the position, and this is basically the time axis. So xt graph for a particle moving along a straight line. So the particle is moving along a straight line is shown in figure. So you have this figure. Now you are basically asked to find out the average speed of the particle in time interval from t is equal to 0 to t is equal to 6 seconds, right? So we know that, what we all of us know that what is the average speed. So for average speed, what we can write is, average speed is nothing but total distance by total time, right? So this is my average speed. Let us now calculate the total distance here. So for example, if I name this, so this is my region 1, this is my region 2, this is my region 3, and this is my region 4, right? So for region 1, I have the distance d1, I can say is nothing but, so it is covering a distance, you see 10, right? So 10 meter. Okay. Now for the region 2, I can say that it is not covering any distance. It is basically constant. The distance covered is same. So it is not changing. So d2 I can say is basically 0. d3 is how much? You see it is 20 minus 10. So we are having 10, okay, and d4 is nothing but, it is the also the distance covered is basically 20 minus 0. So it is basically 20 meter. So my total distance covered becomes, I can say that d total is nothing but, I am going to sum up d1 plus d2 plus d3 plus d4. So it is going to give me 10 plus 0 plus 10 plus 20. So this is going to give us 40, right? And the total time taken, you see the total time taken. So we are actually asked to find it out from t is equal to 0 to t is equal to 6. So time total is basically nothing but 6 seconds. So your average, S average becomes 40, total distance covered by total time taken 6. So your answer is 40/6 meter per second. Thank you. Let us come back.